Okay, looking at Unit 2, the semester review packet. Alright, we're going to be doing lesson or Unit 8A today. Just a reminder, again, these videos are not to be copied like notes were during the year. You should be doing these problems first, alright, and then come into these videos to either check your answer or if you are completely not sure how to do something. Alright, but you should try, meaning put pen to paper on every single problem before watching this video. Alright, let me skip over that. Alright, here we go. Unit 8A, graphing linear equations. Alright, one of the first things we learned how to do was to determine if a point that was given to you was on a line. Okay, so this should sound or look very similar because we did this in the last unit of the year, Unit 11, with systems of equations, and it's basically the same thing. We take our x value and we take our y value in a given point, we plug it in and see if it works. Okay, so in other words, alright, 9 equals negative 2 times negative 3 plus 3. Alright, again, I'm plugging my 9 in for y, alright, because that's the y value, and my negative 3 in for x. Alright, and when I do that, I end up with 6 plus 3, which of course is 9. So A is one of the solutions. Now you'll notice it says circle all that apply. Alright, that's the same idea as selecting all. You got to be aware that there could be possibly more than one answer. Alright, so we're going to repeat that process the same exact way. I'm going to put the 2 in for y. I'm going to put my 0 in for x. Alright, and it's going to look like this. We got 2 equals negative 2 times 0 plus 3. Anything times 0 is 0. 0 plus 3 is 3. B is not one of those solutions. Alright, I'm going to go a little bit faster with C and D. Alright, when I plug my 4 in, negative 5 times negative 2 is positive 10. Positive 10 plus 3 will never be 4. Alright, let's do the last one. My 3 in for y. Negative 2 times 0 would be 0. 0 plus 3, of course, is 3. So A and D are the two that work. Alright, looking at the next set of examples, we're asked to determine or find the slope between the 2 points. Alright, so in order to do this, we have to recall the formula for finding slope, which was the change in y, or y2 minus y1, over the change in x. Alright, in our ordered pair, we always said the first one was x1, y1, and the second one was x2, y2. So in order to find my slope, all I have to do is 12 minus 8 divided by 2 minus negative 5. Okay, and you got to be really careful with your sign work here. Alright, so on top we end up with 4, and on the bottom, after I do leave, change, I end up with 7. That is simplified. That is my answer. Okay, moving on to the next one. Alright, this is my first one, x1, y1. This is my second one, so it's x2, y2. I do 6 minus negative 4 over 3 minus 0. And that's going to be, once again, leave, change, that's going to be 10 over 3, which also cannot be simplified. So there is your final answer. Remember, slope must be in fraction form. Always simplify if you can. Alright, moving on to problem number 4. Again, here's my first point, and here's my second point. I'm going to have 15 minus 11 over 5 minus 5. That's going to be 4 over 0. And now we get to this point where we have to remember, is this 0 or undefined? And one of the clues that we gave you back in Unit 8A was when the 0 is under on the fraction, it's undefined. Okay, and we use the abbreviation UND, which happens to be the first 3 letters of the word under. When the 0 is over, and I'm going to put this in a different color because it's not going on in this problem, so I'm going to put it over here. When the 0 is over, your slope is 0. Alright, so it's all based on the position of the 0 when it comes to simplifying. Okay, the next set of problems we're looking at, there's 6 graphs that we have to do. Okay, and it's either an equation or an inequality, and if you look, you can see all 6 equations or inequalities here. you'll notice 9 and 10 are both inequalities. All right, they're inequalities once again because they have that sign right there and right there. All the other ones are equations because they have equal signs. All right, and there's a big difference in how you finish these problems. All right, and we'll talk about that more when we get down to 9 and 10. All right, so graphing, we learned basically two main ways of graphing. All right, when x and y are on the same side, we said we like to do the cover-up method. Now, some of you may choose to solve for y and use slope-intercept form, and that's completely fine. You can do that. I'm not going to do that, though. All right, so if I eliminate the negative y, what's left is 4x equals 8. And again, the reason why I'm eliminating this is because I understand that in my x-intercept, the y value is 0. So I'm putting a 0 in place of y and solving for x. When I divide here, I end up with my x value equaling 2. So that's the point 2, 0. I'm going to repeat that process for the y. I'm going to say, okay, for the y-intercept, the x value has to be 0, which will leave me with this. Notice, I did not lose my negative sign. All right, the most common mistake people make happens right here. All right, make sure you include the sign in front of your variable. And the reason why that's important is because I'm going to divide by -1. My y value is going to be -8. So I have the point 0, -8. All right, so I go down 1, 2, 3, 4, 5, 6, 7, 8. And there's my y-intercept. And as we've done many times before, make sure you're using a straight line. Draw all the way through. All right, this should be very easy considering, once again, this is something we did quite a bit in Unit 11. All right, which we just finished. All right, looking at number 6. Once again, I'm going to use the cover-up method, and I'm going to kind of not show as much work this time. When I cover up this piece right here and take it out, what's left is 5x equals 10. When I divide by 5, I get x equals 2. So x equals 2 is right there. That's the point 2, 0. Now I'm going to come back and eliminate the 5x. I'm going to divide by -2, and I get y equals -5. 1, 2, 3, 4, 5. And that's the point 0, -5. That's the y-intercept. Alright, now I'm going to make a solid line going all the way through my graph. Alright, use a straight edge, a ruler, an ID, something to help you make that line. Okay, that's using x and y intercepts to graph when you're in standard form. All terms that you should be very familiar with. Alright, now example 7, we're in slope-intercept form. Slope-intercept form allows me to graph with with relative ease. Alright, we have the slope is 2/1, and my y-intercept is 0, -3. So that tells me to start at -3, go up 2 and to the right 1, up 2 and to the right 1. Remember, always go to the right with slope unless you're out of space and you have to work backwards. Alright, so once again I create my line. That's a lot easier than finding the intercepts, but again it depends on how your problem is written. That determines which method you get to graph with. Alright, let's move on to the final 3. Once again, I'm in slope-intercept form. I know my slope is -2/1. I know my y-intercept is 0, +3. So I'm going to go up to 3, place my dot. From there, negative tells me to go down, always to the right. Down 2, 1, 2, to the right. Down 2, to the right, and so on. And we end up with a line that looks like this. Again, you want your line to be straight and go all the way through your graph. Alright, so that's what we call a linear equation, and we were just, in the previous 4 problems, graphing linear equations. Now we're going to be graphing linear inequalities for the last 2. And again, I've already highlighted the difference between these 2 problems and the previous 4. Alright, when it comes to actually graphing these, there really is no difference. Okay, we're going to say in this one, my slope is -2/1, my y-intercept is 0, 4. So I go up 1, 2, 3, 4. I place my dot. I go down 2/1, down 2/1, down 2/1. All right, now this is where inequalities are different. I have to determine what type of line I'm going to make and how I'm going to shade the graph to show all of the possible solutions. So when I look at this sign, it says less than. That tells me because there's no line under it like that, all right, where it says less than or equal to, it just says less than. I know that this is going to be a dashed line. And because it's less than, I'm going to shade under it. All right. So when I go to graph, should I pick the right one here? All right. I'm going to graph a line that is not a solid line. So it has little breaks in it because that line is not included in the answer set. All right. From there, I have to shade. Remember, there's two sides of the line. There's above and below, or up and under. Okay. And we determine that based on the y-intercept. So when I go here and I want to go less than that or under it, that's down this way. So it's under is over here. Okay, it's not left and right. That's what a lot of people get confused on when they see these problems. They think, oh, left is always less than, and that's really not true. All right, so you got to be really, really careful. All right, when we shade. Okay, last one, number 10. All right, I'm going to do the same thing as I did in problems 5 and 6 up there. Okay. And that is, I'm going to use the intercepts method. Now, this one's easy to solve for y. You could just subtract the 3x and use slope-intercept form. But I want to show you what happens when you're graphing inequalities that are in standard form. All right, so what I'm going to do, again, is cover up the y, divide by 3. So I get x equals 2. That's the point 2 comma 0. And then the y is just going to be equal to 6. So that's 0, 6. So I got 2, 0. 1, 2, 3, 4, 5, 6, 0, 6. All right. I have a solid line. But now because we're in standard form, we cannot read the sign. Instead, what we need to do is test a point. So I'd like to review testing a point once I get my line in there. All right, so there's my line. I want to extend it all the way. There we go. All right, testing a point works like this. We take a point that's not on the line. If 0, 0 is available, use it. All right, because it's so easy to use. I plug 0 in for x and y. That's going to give me a 0 on this side, greater than or equal to 6. And then we have to ask ourselves that question. Is 0 greater than 6? Obviously, the answer is no, so we're going to go away on the shading here. All right. Now, you may be looking at this and saying, wait a second, that sign said greater than. Greater than means up, and that's exactly what you're doing here. Well, you got to be really careful with standard form because that doesn't always work. So if you're graphing out of the intercepts, you need to be testing points to shade. Don't read the inequality sign. If you're graphing out a slope-intercept form like we did in number 9 here, all right, you could read the inequality sign to shade. Or you could test a point. You could always test a point for either of the two situations. All right, that is it for Unit 8A. Good luck on your finals.